Hi guys, welcome to enginerdmath channel. So we're live. Our topic will be all about operations on complex numbers in rectangular form. Okay, so this will be for your advanced engineering mathematics subject, and we will start the discussion all about complex numbers. So the first topic that we will have will be operations on complex numbers in rectangular form. Okay? Take note, we will just be doing or performing operations in rectangular form first because complex numbers can have different forms. It can be written in rectangular form. It can also be written in polar form or in exponential form. Okay? So let's define first, or let's give the representation of complex numbers in rectangular form. So usually we denote the complex number by variable z, and if it's in rectangular form, this will be given as x plus I y, where x is the real part and IY is the imaginary part. So X and Y here are real numbers. And this I, okay, is the imaginary unit or number. Which is, if we define, we have I is equal to square root of negative 1. Okay, or if we square both sides, we can have I square is equal to square root of negative 1 square is negative 1. So when performing operations on complex numbers in rectangular form, we will take note of this value for I square, which is equal to negative 1. So we encounter complex numbers, particularly when we are solving quadratic equations that have imaginary roots or complex conjugates roots, right? So that's why it's important in mathematics, the concept of complex number. There are also other applications for complex numbers. That's why mathematicians develop this imaginary number unit I, or the whole complex number itself. Okay? So, we will start with addition and subtraction of complex numbers. So, it is the easiest operation among the four operations in complex numbers, the addition or subtraction, because we will have addition, subtraction, multiplication, and division. Okay? So, how do we add, subtract, or combine complex numbers in rectangular form? Let's say we have A plus BI plus C plus DI. So this is for addition. We just need to combine the real parts, and we also need to combine the imaginary parts. So for the real parts, we have A and C. So if we add them, we will have A plus C, then plus the imaginary parts. Let's combine them. We have BI plus DI, or we can factor out the I. So we will have B plus D quantity times I. So it's just like combination of same terms in algebra. Okay. Next, For subtraction, we have a plus bi minus c plus di. So we need to subtract same terms. So for the real parts, we have a minus c plus for the imaginary part, we have bi minus di. Again, we can factor out the I. We can have plus b minus di. Okay. So this is how we add or subtract complex number. Basically, we just need to add similar terms. When we are adding complex numbers, we combine all the real parts and then we combine all the imaginary parts. Likewise, in subtraction, we just need to subtract the real parts plus the difference of the imaginary parts. Now, I will introduce also to you the concept of conjugate. Okay, complex conjugate. So the definition for complex conjugate is that, let's say, we want to find the complex conjugate of the complex number x plus iy. Okay? It is denoted by x plus iy with a line above or bar above. It denotes that we're getting the complex conjugate of this complex number x plus iy. So it's just equal to x. Then get the additive inverse of the imaginary part. So additive inverse means you just need to get the opposite sign of the imaginary part. So if we have positive iy, its opposite will be minus iy. So basically, in getting complex conjugate of a complex number, you just need to copy the real part, x, and then get the additive inverse of the imaginary part. So if it's positive, turn it to negative, while if it's negative, turn it to positive. Also, if we try to find the complex conjugate of x minus iy, so again, you just need to copy the real part x. This time, the imaginary part is negative iy. So its additive inverse is positive iy. Okay, so let's solve some problems to illustrate how to add and subtract complex numbers. So we have to perform the operations on complex numbers. Okay, for number 1, we have 5 plus 3i plus 2 plus 7i. Okay, we can combine the real part. We will have 5 plus 2. Then, we can also combine the imaginary part. We have 3 plus 7i. So 5 plus 2, that will be 7. And then 3 plus 7, that will be 10i. Okay, for number 2, negative 2 plus 8i plus negative 9 minus 10i. Again, we can combine the real part. Since we have addition, we add them, negative 2 plus negative 9, then plus the real part, we have, the imaginary part, we have 8 plus negative 10i. So negative 2 plus negative 9, that's negative 11. And then 8 plus negative 10, that's negative 2. So we have negative 2i. Next, number 3, negative 5 plus 11i plus 7 plus 23i plus negative 12 minus 15i. So we need to add 3 complex numbers. So let's combine the real parts. We have negative 5 plus 7, then plus negative 12, plus, let's also combine the imaginary parts. We have positive 11 plus 23, then plus negative 15i. So let's simplify. We will have negative 5 plus 7 plus negative 12. That will be negative 10, right? Then for the imaginary part, combine 11 plus 23 plus negative 15. That will be positive 19. Okay? 19i. So this is the answer. Next, number 4. 2 times 5 minus 3i plus 3 times negative 7 plus 8i. So this time, we have to multiply first the constant in front of the complex numbers. So we can distribute them, multiply each term, the real and imaginary part of the complex number by 2. So we will have 2 times 5 plus 2 times negative 3i. Also, for the 3, we can multiply each term, the real and imaginary part by 3. We will have 3 times negative 7 plus 3 times 8i. Then simplify, we will have 2 times 5, that's 10. 2 times negative 3i, negative 6i. Then plus 3 times negative 27, that will be negative 21. Then 3 times 8i, that will be positive 24i. Now we can combine real parts and imaginary parts. So for the real parts, we have 10 plus negative 21. Then for the imaginary part, we have negative 6i and 24i. So we have negative 6 plus 24i. Simplify, negative 10 plus negative 21. Okay, that will be negative 11, right? Then for the imaginary part, negative 6 plus 24, positive 18i. So this is the final answer. Okay, next for number 5, 8 plus 5i minus 10 plus 14i. So this time we have subtraction. So we will subtract the real parts and we will subtract the imaginary parts. For the real parts, we have 8 minus 10. Okay, plus the difference of the imaginary part, we have 5 minus 14i. Okay. So we will have 8 minus 10, that's negative 2. Then 5 minus 14, that's negative 9i. Or you can think of subtraction of complex number as this. You can just distribute first this negative sign here. It means a coefficient of -1. So you can remove first this parenthesis by distributing this negative sign to each term on the complex number. So you can have 8 plus 5i, and then we have -10 minus 14i. And then proceed to combining similar terms. So you can combine the real part, 8 minus 10, plus the imaginary part, 5 minus 14i. Okay? So same answer, 8 minus 10, -2. And then 5 minus 14, -9i. Okay, next, number 6. -11 plus 7i minus 12 minus 25i. So we have subtraction again. We can distribute this negative sign. We will have -11 plus 7i, just copy, minus 12. Then we will have negative of -25i, positive 25i. And then we combine the real parts. -11 minus 12 plus the imaginary parts, we have 7 plus 25i. Okay, so -11 minus 12, -23. Then 7 plus 25, 32i. Okay, number 7. What if -3 plus 7i minus 4 plus 5i minus 16 minus 21i? Okay, so we can distribute first this negative sign. So we will have -3 plus 7i, then -4 minus 5i, then -16. So negative times -21, positive 21i. So we can now combine similar terms for the real parts, -3, -4, -16. So -3 minus 4 minus 16 plus the imaginary part, 7i, -5i, and 21i. So 7 minus 5 plus 21i. Simplify, combine, -3 minus 4 minus 16. -23, right? Here, 7 minus 5 plus 21, that's 23. Positive 23i. So this is the answer. Next, number 8. What if -4 times 2 plus I minus 7 times 8 minus 9i? So, distribute first the constants, right? Or let's multiply -4 to real and imaginary part first. So, -4 times 2 plus -4 times I. Also in -7, let's multiply. So -7 times 8, then -7 times -9i. So -4 times 2, that's -8. Then -4 times I, that's -4i. -7 times 8, -56. Then, -7 times -9, positive 63i. Okay, let's combine the real parts. So, -8 minus 56. The imaginary part, we have -4 plus 63i. So negative 8 minus 56, that's negative 64. And then negative 4 plus 63, positive 59i. Okay. Next, for number 9, we have negative 4. Sorry, this is already. We have 5 plus 7i plus 2 times 3 minus 5i minus 8 plus 3i. So we have both addition and subtraction. Okay? So we can distribute first these two, multiply, and we can distribute this negative sign. We will have 5 plus 7i, just copy. 2 times 3. Okay, let's multiply now. 2 times 3, that's 6. 2 times negative 5i, negative 10i. Then distribute the negative. We will have negative 8 minus 3i. Okay, combine the real parts. So, 5 plus 6 minus 8. Combine the imaginary parts. You have 7i. So, 7 negative 10i minus 10 minus 3i. So, 7 minus 10 minus 3. Let's combine. So, we have 5 plus 6 minus 8. So, that's 3, positive 3. Then 7 minus 10 minus 3. That's negative 6. Okay. I. Okay, next for number 10, negative 7 plus 8i conjugate minus 2 square root of 3 plus I plus 4 times 3 plus square root of 2i. Okay, so we have conjugate. So I already gave you the definition to find the conjugate of complex number. So what is the conjugate of negative 7 plus 8i? So just copy the real part, negative 7, and then get the additive inverse or opposite sign of the imaginary part. So since we have positive 8i, its opposite or additive inverse is negative 8i. And then we can distribute, multiply this negative 2. We will have negative 2 square root of 3 minus 2i. Also here, we can multiply 4, distribute. So 4 times 3, that's 12. Then 4 times square root of 2i, positive 4 square root of 2i. So we can now combine the real parts and imaginary parts. For the real parts, we have negative 7, negative 2 square root of 3, and then positive 12. Okay. For the imaginary part, we have negative 8i, negative 2i, and then plus 4 square root of 2i. So, negative 7 minus 2 square root of 3 plus 12. So, what we can combine is just the whole numbers, negative 7 plus 12. That's equal to positive 5. And then, let's just copy this minus 2 square root of 3 because we cannot combine this with 5 since it has a an irrational part, which is square root of 3. Okay? So the real part of the complex number consists of 5 minus 2 square root of 3. So this will be an irrational number due to the presence of the square root of 3. Okay? Plus, for the imaginary part, let's combine negative 8 minus 2 plus 4 square root of 3. So likewise, what we can combine here is just negative 8 and negative 2. Okay, so that will be negative 10. Then copy plus 4 square root of 2. Again, because it has an irrational part, which is the square root of 2. Okay? So we also have an irrational imaginary part due to the presence of square root of 2. So this will be the exact value of the complex number. So you can use calculator. You can also have this the equivalent approximate decimal for this complex number. Okay, later I will show you how to use calculator to check our answers, because we can use calculator to perform different operations on complex numbers. Next, we have 11. Okay, what if we have 3/4 plus I, then plus 3 times square root of 5 minus 1/2 I minus negative 2/3 plus square root of 7I conjugate. Okay. So we have a conjugate again. The conjugate of negative 2/3 plus square root of 7I. So let's find first its conjugate. So let's copy the first two complex number. So 3 plus 4I plus 3 times the square root of 5 minus 1/2 I. Then minus, so the conjugate of negative 2/3 plus square root of 7I will be, so copy the real part, 2/3 negative, and then get the additive inverse or opposite of square root of 7I. It's positive square root of 7I. Its opposite is negative square root of 7I. And then we can distribute this 3, also this negative sign. We will have 3/4 plus I, then plus 3 square root of 5, then 3 times negative 1 up, that's negative 3 halves I, right? So distribute the negative, this will be positive 2/3 positive square root of 7I. So we don't have grouping symbols anymore. We can combine similar terms. So for the real parts, 3/4 plus 3 square root of 5 plus 2/3. Okay. Plus, combine the imaginary parts. We have I, or that's equivalent to 1I. So we have 1. Then minus 3 halves I plus square root of 7I. So we can simplify this. Let's combine as a single fraction. So we have 3/4, 3 square root of 5. This has an invisible denominator of 1 and 2/3. So get the LCD. What is the LCD, or least common multiple of the denominators for 1 and 3? Obviously, that's 12, right? So 12 divided by 4, that's 3, times 3, 9. Okay? Plus 12 divided by 1, 12, times 3, 36, square root of 5. Plus 12 divided by 3, that's 4, times 2, 8. Okay? Plus, also, let's combine this as a single fraction. So this one has an invisible denominator of 1, square root of 7, invisible denominator of 1. So what is the LCD of 1, 2, and 1? Obviously 2. So 2 divided by 1, 2, times 1, 2, minus 2 divided by 2. Okay, that will be 1 times 3, 3, plus 2 divided by 1, 2, times square root of 7, 2 square root of 7I. And then we can still combine here on the real part. On the numerator, what we can combine is just 9 plus 8. Right? So 9 plus 8, that's 17. And then let's just copy this plus 36 square root of 5 again, because it has an irrational part, square root of 5 over 12. Okay, and then plus, likewise here, we can combine further the whole numbers, 2 minus 3, that's negative 1. And then just affix or copy this 2 square root of 7 because it also has an irrational part square root of 7. So this is the exact value of the complex numbers. Okay, for number 12, okay, what if we have 5i times 3 plus 2i minus 2i times negative 2 plus I? Okay, so we can multiply first, distribute 5i and negative 2i. So 5i times 3 plus 5i times 2i. Then we have negative 2i times negative 2, then negative 2i times I. So 5i times 3, that's 15i, right? Plus 5i times 2i, that's 10i squared because I times I, applying law of exponent, that's I squared. Then minus negative 2i times negative 2. So actually, it will become positive 4i. Then negative 2i times I, negative 2i squared. Okay, so we can combine 15i plus 4i. They are similar terms. So that will be 15 plus 4, 19i. Plus, so for this 10i squared, remember the definition for I squared that we had on our introduction. I is equal to square root of negative 1. When we square both sides, I square is negative 1. So therefore, we can replace I squared with negative 1. Okay. Then also, negative 2. This 4i is already combined with 15i, right? It becomes 19i. So for negative 2i squared, again, the I squared, we can have I squared as negative 1. So simplifying, so 19i, 10 times negative 1, negative 10. Then negative 2 times negative 1, positive 2. So these are both real parts. So combine negative 10 plus 2, that's negative 8. Okay, so negative 8 and then the imaginary part will be positive 19i. So this is the final answer. Okay, 12, 13. Okay, for 13, what if negative 3i times 4 plus 5i plus 7 times negative 2 plus 6i minus I times negative 1 plus I. Okay, we can multiply first, distribute. So negative 3i, okay, let's multiply. Negative 3i times 4, that's negative 12i. Negative 3i times 5i, negative 15i squared. Okay. Next, 7 times negative 2, negative 14. 7 times 6i, positive 42i. Next, negative I times negative 1, positive I. Negative I times I, negative I squared. Okay, so we can actually combine the imaginary parts already. We have negative 12i plus 42i plus I. So negative 12 plus 42 plus 1i, right? Okay. And then again, this I squared can be written as negative 1 or it's equivalent to negative 1. So we will have negative 15 times negative 1 and then negative 14 We haven't combined yet this negative 14 because this is just a real part. So copy negative 14, positive 42I also already here, positive 1I already here, then minus I squared. Again, the I squared is equivalent to negative 1. Okay, so combine negative 12 plus 42 plus 1. That will be 31, 31I. Okay. Then we will have negative 15 times negative 1. That's positive 15 minus 14, negative times negative 1, positive 1. So we can combine 15 minus 14 plus 1 because they are all real parts. So 15 minus 14 plus 1. Obviously, that's 2, right? Positive 2. Or let's write first the real part 2 followed by the imaginary part plus 31i. So this is the answer. 2 plus 31i. Okay. Next, 14. Okay, for 14, what if I raised to 37? Okay. How do we simplify or evaluate imaginary number I raised to certain exponent which is an integral exponent no matter how big it is? Actually, there is a pattern. Okay? So, let's start with the first power of I to the first. Obviously, that's equal to I. How about I squared? We already know it's equivalent to negative 1, right? How about I cube? So we can split the power of I cube into I squared times I to the first. So that if we add up the exponent 2 plus 1, it's equivalent to 3I cube. Okay, we know that I squared is negative 1, right? So we have negative 1 times I to the first or simply negative 1 times I negative I. How about I to the fourth? This time we can split the power I to the fourth into I squared times I squared. But we already know that I squared is equivalent to negative 1. So we have 2I squared. We multiply negative 1 times negative 1. And negative 1 times negative 1, that's 1. Okay, now if we continue, if we have I to the fifth, so we can split the power as I to the fourth times I to the first or I, right? So that 4 plus 1 is 5. But we know that I to the fourth is 1 times I to the first or I. 1 times I, it's I. Next, I to the sixth. So we can split the power into I to the fourth times I squared because 4 plus 2 is 6. But we already know that I to the fourth is 1, right? And also, we already know that I squared is negative 1. So we will have 1 times negative 1 or negative 1. How about I to the 7? Okay, I to the 7, I can split the power into I to the 4 times I cube. So that 4 plus 3 is 7. But I to the fourth is 1, and we already know I cube is equal to negative I. So we can replace I cube with negative I. Multiplying 1 times negative I, that's negative I. Next, I to the 8. So we have I to the fourth times I to the fourth. I can split the power of I to the 8 as I to the fourth times I to the fourth since 4 plus 4 is 8. Next, we already know that I to the fourth is 1, right? So you have 2 I to the fourths. We have 1 times 1. And 1 times 1, that's 1. So see, we have a repeating patterns for the powers of I. So for the first 4 power, I to the first to I to the fourth, it corresponds to I, negative 1, negative I, 1. Likewise, from I to the fifth to I to the eighth, it is the same as the first 4. It's I, negative 1, negative I, and 1. So what does it mean? Okay, to simplify the powers of I raised to a certain exponent, integral exponent, no matter how big it is, you just need to get the remainder when you divide that power by 4. Since every fourth power of I, the pattern repeats, right? So to have the simplified form of I raised to something, get the remainder when you divide that exponent by 4, and that remainder will dictate or will tell you what is the corresponding uh, value of that I raised to certain power. It can be either one of the four. It's I, negative 1, negative I, or 1. So if the remainder is 1, it's equivalent to I. If the remainder is 2, it's equivalent to negative 1. If the remainder is 3, it's equivalent to negative I. And if the remainder is 0, okay, 0 because if you divide, if when you divide an exponent or an integer by 4 and the remainder is 0, it means it is divisible by 4. So the remainder is 0, right? You will have the value equal to 1. Okay? So applying that concept here. So I to the 37, we can just divide, okay, 37 by 4. So 37 divided by 4, how many? 9, right? 9 times 4, 36. 37 minus 36, 1. So the remainder is 1. Or to visualize this, I can write also I raised to 37 as I to the 4th raised to the 9th. This is the quotient. Then since we have a remainder, we still need to multiply I raised to that remainder 1. Right? Because if you apply law of exponent, that's I raised to 4 times 3, power to power law, 36, times I to the first, and multiplying same base I, copy, add the exponent, 32 plus 1, 33. Sorry, 36. 36 plus 1, 37. So, you just return to the original given, right? But on this form, it's easy to simplify because we know that I to the fourth is 1, right? Raised to 9 times I to the first, or I. And I to the 1 to the 9, it's still 1 times I, or simply I. And like what I've said, since the remainder is 1, it corresponds to the value of imaginary number I. Okay? So therefore, it is just equal to I. Okay, next, number 14, 15. What if 2I to the 59 plus 3I to the 14? So, for 2I to the 59 first. So, 2 times, let's get the remainder when we divide 59 by 4. Okay, 5 divided by 4, 1. 1 times 4, 4. 5 minus 4, 1. Bring down the 9. 19 divided by 4, 4. 4 times 4, 16. 19 minus 16, 3. Remainder 3, right? So, therefore, when the remainder is 3, like what I've said, it's equivalent to I cubed negative I. So, therefore, I to the 59 is negative I. Plus, okay, 3, I to the 14. So, what is 14? Let's divide again by 4. Obviously, that's just 3, remainder 2. Okay, so therefore, the remainder is 2. It's equivalent to, when the remainder is 2, it's equivalent to negative 1. Simplifying, we will have 2 times negative I, negative 2I. Then 3 times negative 1, negative 3. Or writing first the real part, we will have negative 3 minus 2i. Okay, next. 16. Okay, what if we have negative 5i raised to 104 plus 7i raised to 181 minus 10i raised to 239 plus 15i raised to 382. Okay, so for the first term, negative 5i to the 104. So negative 5, again, we have an exponent of 104. Let's divide it by 4. So you can also use calculator so that you won't have to divide manually. Okay, I will use calculator. Okay, so I will divide 104 by 4. So 104 divided by 4. Okay, it's exactly equal to 26. So therefore, there is no remainder because you have an exact quotient of 26. So when the remainder is 0 or there is no remainder, it means, like what I've said here, when the remainder is 0, it is equivalent to 1. So I to the 104 is just equal to 1. Plus, okay, 7i raised to 181. So let's divide 181 by 4. Okay, this time we have a remainder because it turns out to be a fraction. Okay, so the technique here to get the remainder when using calculator, so once you have this as a fraction, transform this into decimal. Press this button, then subtract from this answer the whole part. Okay, 45 minus 45. Okay, and then you multiply by 4. Since we're dividing by 4, right? Multiply by 4, you will get the remainder 1. Okay, so since the remainder is 1, it is equivalent to I to the first or I. So I to the 181 is just I. Next, negative 10. Okay, we have I raised to 239. So let's divide 239 by 4. Okay, again, it's not exact, therefore there is a remainder. Press this button, transform to decimal. Subtract from this answer the whole part, 59 minus 59. Okay, and then multiply by 4. So this is the remainder, 3. So when the remainder is 3, it means it is equivalent to negative I. Okay, for positive 15, I to the 382. Okay, let's divide 382 by 4. Again, there's a remainder. Transform to decimal, press this button. Subtract from this the whole part, 95 minus 95. And then times 4. So the remainder is 2. When the remainder is 2, it is equivalent to negative 1. So I to the 382 is just negative 1. Okay, now we can simplify. So negative 5 times 1, negative 5. Plus 7 times I, 7i. Negative 10 times negative, this is negative I, right? Positive 10i. And then 15 times negative 1, negative 15. So we can now combine similar terms. So the real numbers, or the real part, I mean, we have negative 5 minus 15 plus the imaginary part, 7 plus 10i. So negative 5 minus 15, negative 20, plus 7 plus 10, 17i. So this is the answer. Okay, next. 16, 17. What if negative 3 plus 5i minus 2 times 7 plus 2i minus I raised to 1023 plus 4I raised to 2456. Okay. So, we can distribute first is negative 2. So, copy negative 3 plus 5i. Then, multiply negative 2 times 7, negative 14. Negative 2 times 2i, negative 4i. Okay. And then, for the powers of I here, we have negative of I to the 1023. So again, let's apply the shortcut. Let's divide the exponent 1023 by 4. So there's a remainder because it is a fraction. Convert to decimal, press this button. Subtract from this the whole part, 255. So minus 255. Then times 4. Okay, the remainder is 3. So therefore, it is equivalent to negative I based on the pattern, right? Next, plus 4. Again, 2, 4, 5, 6. Let's divide by 4. Okay, it's exactly equal to 614, meaning the remainder is 0. So when the remainder is 0, it means it's equal to 1 based on the patterns above, right? Okay, so we can now simplify further. So negative 3 plus 5i minus 14 minus 4i, negative of negative I, positive I, then 4 times 1, 4. So combine the real part. Negative 3, negative 14, and positive 4, plus the imaginary parts, positive 5i minus 4i plus 1i. Okay, combine. Negative 3 minus 14 plus 4, negative 17 plus 4, negative 13. Then 5 minus 4 plus 1, 1 plus 1, 2. Positive 2i. So this is the answer. Okay, next, 17, 18. Okay, negative 3i times negative 1 plus 2i minus 7 plus 5i conjugate minus 8i, okay, raised to 1410 plus 6i raised to 2277. Okay, let's distribute this negative 3i first. Let's multiply. So negative 3i times negative 1, positive 3i. Then negative 3i times 2i, negative 6i squared. Okay. Then minus, we need to get the conjugate of 7 plus 5i. So how to get the conjugate again? Copy the real part, 7. Then get the opposite sign of the imaginary part, positive 5i. Its opposite is negative 5i. Minus 8. So we have power of I raised to 1 4 10. So let's divide 1 4 10 by 4. Okay, it is a fraction, therefore there's a remainder. So transform to decimal, press this button. From this answer, subtract the whole part, minus 352, then times 4. The remainder is 2. Oh, when the remainder is 2, it means it's equivalent to negative 1. Okay? Plus 6i to the 2277. So 2277, let's divide by 4. Okay? Transform to decimal, press this button. Okay, subtract the whole part, 569. So minus 569, then times 4. Okay, the remainder is 1. When the remainder is 1, it's equivalent to I based on the pattern. Okay, let's simplify further. So, 3I minus 6. Ito, this I squared is equivalent to negative 1, right? Let's distribute this negative sign. We have negative 7 plus 5i. Negative times negative 5i, this will become positive 5i. Then negative 8 times negative 1, positive 8. Then copy 6i. So 3i, negative 6 times negative 1, positive 6, minus 7 plus 5i plus 8 plus 6i. We can combine the real part first. So 6 minus 7 plus 8. And then the imaginary part, so 3i plus 5i plus 6i. So 6 minus 7 plus 8, 7, right? Plus 3 plus 5 plus 6, 14i. So this is the answer. Okay, next, 19. What if 2 times 4/5 plus square root of 2/3 I minus I times square root of 3 over 2 plus 1/4 I plus 1/3 I raised to 576 plus square root of 2I raised to 981. Okay, let's distribute first these two, multiply. 2 times 4/5, 8/5, right? Plus 2 times square root of 2 over 3i. 2 square root of 2 over 3i. Okay, let's distribute also negative I. Multiply. So, negative I times square root of 3 over 2. Square root of 3 over 2, I, negative, right? Negative I times 1/4 I. Negative 1/4 I times I squared. Okay, here, for 1/3 I to 576. So, let's divide the exponent 576 by 4. Okay, it's exactly equal to 144, meaning there's no remainder or the remainder is 0. So if the remainder is 0, it means it's just equal to 1 based on the pattern above. Next, plus the square root of 2, I to the 981. So let's divide 981 by 4. Okay, so there's a remainder since it is a fraction. Transform to decimal, subtract the whole part minus 245, then multiply by 4. Okay, so the remainder is 1. So when the remainder is 1, based on the pattern above, it's just equivalent to I. So simplifying, we will have 8/5 plus 2 square root of 2 over 3i minus square root of 3 over 2i minus, okay, negative 1/4 I squared is negative 1. Okay, plus, so 1/3 times 1, 1/3 plus square root of 2i. Copy. So this will be, okay, let's simplify this to negative 1/4 times negative 1. It will become positive 1/4. Okay, we don't have any more grouping symbol like parentheses, so we can combine similar terms. Let's have the real parts first. So 8/5, what else? Plus 1/4 plus 1/3. Okay, these are the real parts. For the imaginary part, we have 2 square root of 2 over 3 minus square root of 3 over 2 and then plus square root of 2i. So we can combine this as a single fraction. Get the LCD or the least common multiples of the denominators 5, 4, 3. Obviously, that's 60, right? Okay. So, let's divide. 60 divided by 5, that's 12 times 8, 96 plus 60 divided by 4, 15 times 1, 15 plus 60 divided by 3, 20 times 1, 20. Also here, let's combine as a single fraction. So this square root of 2 has an invisible denominator of 1. So what is the LCD or the least common multiples of the denominators 3, 2, and 1? Obviously 6, right? So 6 divided by 3, that's 2 times 2 square root of 2, 4 square root of 2. Next, 6 divided by 2, that's 3 minus 6 divided by 2, that's 3 times square root of 3, 3 square root of 3 plus 6 divided by 1, that's 6 times square root of 2, 6 square root of 2 I. And then we can still combine for the real part the numerators. They are all whole numbers. So 96 plus 15 plus 20. 131, okay, over 60 plus also here over 6 for the numerator. What we can combine is just this 4 square root of 2 plus 6 square root of 2. They are similar terms, right? So 4 plus 6, 10. Square root of 2 minus 3 square root of 3. I. So this is the answer. Okay. Now, as promised, you can use calculator to check if your answers are correct. Okay. So let's check our answers. Let's check if our manual computations are correct. So I will also use this calculator, Casio FX570S Plus. So first step, go to complex mode. So press mode, and then you will see here 2 complex. Press 2, and then you will now see the complex term here on the calculator. It means that you're already in the complex mode, and all the computations that you will perform in this mode will be within the range of complex numbers. So you will just need to input this 5 plus 3i plus 2 plus 7i. Okay? So you have actually no need to put parentheses if it's just addition. So you can just put 5 plus 3i plus 2 plus 7i without the parentheses. Okay, so 5 plus 3i. The I is located here, as you can see. Okay, press this button. Plus 2 plus 7i. So 2 plus 7i. Press equal. So 7 plus 10i. Correct. Number 2, negative 2 plus 8i plus negative 9 minus 10i. Okay, negative 2 plus 8i plus negative 9 minus 10i. Negative 9. Okay, you can put parentheses if you have plus followed by a negative sign. So, plus negative 9 minus 10i. So, negative 11 minus 2i. Correct. Next, negative 5 plus 11i. Negative 5 plus 11i. Then, plus 7 plus 23i. 7 plus 23i. And then, plus negative 12 minus 59. Plus, so put parentheses because it is followed by negative sign. Or you can also, you may not put parentheses, but it's just more appropriate if there's a parenthesis when the plus operation is followed by a negative sign. So negative 12 minus 15i. Okay. So the answer is negative 10 plus 19i. Correct. Here, I have 2 times 5 minus 3i and then plus 3 times negative 7 plus 8i. 3 times negative 7 plus 8i. Okay, negative 11 plus 18i. Correct. Next, for the subtraction, 8 plus 5i minus 10 plus 4i. This time, it is important to put parentheses now when you input in the calculator if the operation is subtraction. Okay? Here, for the first complex number, you may omit inputting the parentheses since this is just the first complex numbers. But if there's a negative sign in front, you must put parentheses. Or if you have other constant than negative 1 like 2, 3, 4, and so on. Okay? So you can just remove this parentheses when you input. So 8 plus 5i minus, so parenthesis is important, quantity 10 plus 14i. Okay, negative 2 minus 9i. Correct. Okay, next. 8 plus 5i minus 10 plus 14i. Actually, this is just the same, no? For 6. So, negative 11 plus 7i minus 12 minus 25i. So, negative 11 plus 7i minus quantity, parenthesis, 12 minus 25i. Negative 23 plus 32i. Okay, this one. Okay, negative 3 plus 7i minus, okay, open parenthesis, 4 plus 5i, then minus, again, open parenthesis, 16 minus 2i. 21i, sorry. 16 minus 21i. Press equal. Okay, you will have negative 23 plus 23i. Next, okay, negative 4 times 2 plus i. Negative 4, parenthesis, 2 plus i, minus, okay, 7 times, so parenthesis, 8 minus 9i. Okay, negative 64 plus 59i. Okay, this one, 5 plus 7i plus 2, 2 times 3 minus 5i minus quantity 8 plus 3i. Okay, 3 minus 6i. Next, so this one, how to input in a calculator when you have conjugate. So, press shift, okay, followed by these two for complex. Then you see the conjugate, or that represents, or that means conjugate. So, press 2, okay, and then you should input inside the conjugate, inside the parentheses, the complex number, negative 7 plus 8i. So, negative 7 plus 8i. So, it will get the conjugate of negative 7 plus 8i. Then, minus, what's that? 2. 2 times, so square root of 3 plus I, then plus 4 times 3 plus the square root of 2i. So, 3 plus square root of 2i. Okay. So, the exact answer is 5 minus 2 square root of 3, correct, for the real part, plus negative 10 plus 4 square root of 2. Okay. So, we have the correct answer. Or you can also convert to decimal. Just press this button. So it's approximately equal to 1.536 in 3 decimal place. Okay, 1.536 the imaginary part minus 4.343. Ay, okay. This one, let's input again. So, 3/4 plus I, okay. 3/4 plus I, then plus 3 times square root of 5. So, square root of 5 minus 1 half I. And then minus, okay, we need to find the conjugate again. So, shift to 2 for conjugate. Then let's input inside the parentheses for the conjugate this complex number, negative 2/3 plus square root of 7i. So you have negative 2/3 plus square root of 7i. Okay, press equal. Okay, so this is the exact answer. 17 plus 36 square root of 5 over 12. We are correct for the real part. For the imaginary part, negative 1 plus 2 square root of 7 over 2. Okay, we got the correct answer. You can also convert this into decimal. Just press this button. So this will be approximately 8.125, again in 3 decimal place, plus 2.146i in 3 decimal place. Okay, so that's it. So that's just how to check your answer using calculator, right? So I think let's end the live stream for now. We will just continue on the next live. Other operations on complex numbers in rectangular form. So maybe we can have division and multiplication. Okay? So thank you for watching. I hope you learned from this live stream. Don't forget to subscribe and like this video and hit the notification bell so that you will be updated when we have we have new video and new live stream in this channel. Okay, so thank you for watching. See you in the next live. God bless everyone. Bye bye.